So I mentioned that we were going to do sort of a step-by-step to actually securing your MongoDB instance, MongoS instances, etc. So let's just go through those. Some of these we'll dive into in more detail, others will be for later lessons where we can actually explore them in the depth that's required. The first thing is to turn authentication on. And that was covered in M102. It hasn't gotten much more complicated since. There are some options that become available when we expand that to include SSL. So we'll talk about those. Those have been added since M102 was recorded, and we didn't go into SSL in M102. So first of all, though, you turn authentication on, and you add users with appropriate authorization. So if a user only requires read access to a single database, that's all they should get. If you are adding a super user, someone who needs to be able to administer and do everything on the system, that's a completely different situation. So you need to add users with appropriate authorization. And actually, as a sub item here, you generally want to add a user admin first. And actually, this is documented pretty well in the security documents. So I'm going to go reference those, as I mentioned I was going to do earlier. So here are the excellent security documents, docs.mongodb.org/manual/security. And although you can get all of the documents in PDF and other formats, EPUB, for example, the way we publish allows us to do that. We specifically call out the fact that you can download this section in PDF form as MongoDB security, and here's the link to it. A lot of people like to have this as reference material. It can be easier to go through in a more static environment than linked HTML pages. But a lot of this will be very familiar to you if you've gone through M102, which is the prerequisite to this course. Enabling talks about role-based access control. We're going to get into that in a second. Authorization, auditing, and encryption. We're going to talk about all of those things. And it really does have an excellent series of tutorials here. A checklist that you should check through to make sure that you've actually considered everything on there as relevant to your environment. Tutorials, user and role management, and even then at the bottom, vulnerability reports. If you do find a security problem in MongoDB, it can be reported, and other reference material there. So certainly a recommended thing to look at. So I mentioned adding a user administrator, and in this tutorial about enabling authentication, you can actually see that it says if you create the user administrator before enabling access control, you will disable the localhost exception, as we discussed. There's also a full procedure then for the recommended way to actually add a user. Key files we're going to talk about in a second, so we'll come back to that. Creating the system user administrator even gives you a sample user password and shows you what the role should look like. So you can copy and paste this, change a couple of fields, and you've got your user just as you needed. So add a user with the appropriate authorization, add a user administrator first. The next thing you're going to want to make sure of is that the hosts themselves, the MongoDB instances, and MongoS's, are using auth. And this is covered by Dwight again. The option here is the key file, sort of like a shared secret. Again, the one caveat, this usually has to have 600 permissions, restricted permissions to the owner only on a Linux system. So chmod 600 is the one there, again covered by Dwight in 102. So they use the key file to authenticate internally with each other and prove that they are valid members of a set. So the key file being identical and consistent across all members of a particular set or cluster is paramount. In 2.6, with the additions we've made to SSL functionality, there is now an alternative to key file, and that's X509 certs. We're going to be covering them in depth in a later module, so I'm not going to cover them here, but they are an alternative to key file that's been added, and a vastly more secure alternative as well. I'm calling this out explicitly: configure roles, appropriate roles for users. This essentially ties into this same thing here. You want users to have the appropriate level of access, but no more. Just best practices when doing it in general. And then another one here, which is really the only network related option in MongoDB besides the port that it runs on, things like that, and that is bind IP. Bind IP sets the IP address that MongoDB and MongoS listen on. And so locking this down to a particular IP address can make things far more secure. That deserves a better explanation. So let's just draw that out for a second. Let's say that this box represents a system, and it doesn't really matter if it's Linux or Windows or anything else for that matter. And let's say that I'm going to use the Linux nomenclature regardless because it's the one I'm most familiar with. Let's say that this is ETH0, which is a physical NIC, the first physical NIC detected by the operating system, and this is ETH1, the second one. and this is a logical diagram only, of course, not physically related to anything. And we'll call this one the loopback, LO, in Linux parlance, and it is 127.0.0.1. So this is the localhost exception that we mentioned before, the loopback address. So this is the one that you're going to be connecting on if you're connecting internally. You connect through here, you get the localhost exception, which allows you to add your initial user, etc. So you've got a MongoD process, or MongoS, but we'll just keep it at MongoD for now, living on this system. And given what we've called it, it's a Linux system. So there we go. So it's a Linux system. You've got these various interfaces. You start MongoD, and if you don't specify something in bind IP, what it will actually do is listen on all interfaces. Okay, so we've already given this one an IP address, 127.0.0.1. That's the default. Let's just say that ETH0 is actually our internal facing interface on this machine, and this has a 10.0.0.1 address. And ETH1 here is an externally facing IP address that goes out to the internet at large, right? So this is going out to the, the internet here, whereas this is an internal network. It doesn't really matter what IP address we give this, but we could say 8.8.8.8, the Google public DNS server. So by default, you start up MongoD, it listens on all of them. If you attempt to connect on, say it's the default port 27017 on any of these interfaces, it will answer you. Right, and then of course you'll have to prove you are who you say you are if you have authentication turned on, etc. And why is that potentially dangerous? Well, if there's no firewall in place or anything else, this is a publicly accessible IP address. One of the more common ways this gets exposed is, say, in a cloud service such as EC2 or one of the other, Google Compute Engine, whatever it is, where you've bound to a public IP address, and then essentially the entire world can see your MongoDB port 27017 and connect to it, right? It's not locked down in any way, shape or form. And you can see why that might be dangerous, right? Particularly if you haven't gotten around to adding users yet, someone finds your MongoDB database and starts, inserting and adding their own users or doing other things to it, or reading your data that you wanted to keep private. So if you instead set bind IP equal to 10.0.0.1, then you get rid of the listening here. MongoD will no longer listen on that interface. So if a request comes in on port 27017, it gets connection refused, nothing happens. And in fact, because we've only specified 10.0.0.1, we've essentially removed localhost access. So if anyone was connecting to this host locally, you'd want to make sure that they connected to this IP address so they wouldn't actually be able to connect. So there you go. That's one way you could have secured it, 10.0.0.1 only. So you would definitely have to make sure that. A more common way is to do your internal IP address and 127.0.0.1. And you can specify 2 or 3 IP addresses that way, just comma separated. So now you're listening on both interfaces again. You can talk locally, so if someone fires up a connection to localhost, it will answer it. And if someone on your internal LAN fires in a connection this way, it will also answer it. Okay? Now, what if we did it the other way around? What if we only specified 127.0.0.1? Well, that's an immediate problem, right? Now the only thing that can talk to this MongoD is other things on this host. Now that might be fine if you've got another, MongoD here, you're running, for test purposes, and you're going to have these really only communicating with each other. So it's essentially just a loop back, hence the name, right? So it goes out here and loops back in again and connects and everything works. But if you put a MongoD anywhere else, internally, externally, anything. So say there's another MongoD over here living on the internal LAN. There it is. If it attempts to address 127.0.0.1, it'll talk to itself, right? It's a loop back address. You try to talk to that, it goes right back in, right? So there is then no way for anything externally to talk to this MongoD process, and you can't do things like replication, right? You can't have it be part of a sharded cluster. You can't have it do replication. It's just not going to work. It's going to fundamentally break how this MongoD works. It's very secure. Only things on this host can actually talk to it, but it also completely breaks its distributed nature. Okay, so if you do lock it down to 127.0.0.1, only things on the local host will be able to talk to it, and you have to be aware of that. There are a couple of ways around things like this, but generally that is going to be the case. So be very careful with how you use bind IP. You can have unintended consequences, and make sure that whatever address it is that your other MongoDs and MongoSs and config servers and clients and applications use to talk to this MongoD, that you are actually listening to it. So Generally, you're not going to want to just bind things to 127.0.0.1.